Okay, we're at the Avere Systems booth right now. Joining me is Bernie Bain from Avere System, technical marketing engineer. How you doing, Bernie?
Fantastic. How are you doing?
I'm doing good. So real quickly, just tell us a little bit about what Avere does. What problems do you guys solve?
Okay, so Avere Systems has come up with this concept of an edge filer. And what that means is we're trying to maintain all the I/O that your clients are generating, your servers are generating at the edge of your network. And the benefits that come with this are essentially latency reduction across the board. And the way that we achieve latency reduction, aside from pushing all the I/O to the edge, is enabling this edge filer to use flash and SAS and RAM caches inside of the system to be able to optimally serve all the I/O, read and write I/O, locally on that for each file that's being manipulated by our clients and servers.
Okay, so basically what I can do is accelerate performance without having to throw out all my existing storage investment.
Exactly. You can actually leverage your existing storage investment from all the vendors that you've bought from in the past and now tie it all together into this global federated namespace that you can access from anywhere as if it were locally to the clients.
Okay, cool. So walk me through what you got here.
Okay, so we have just a typical setup here where we have on the left our compute farm or our workstations. So those are the guys that are generating all the I/O, manipulating the files, trying to get the work done. And what you do here is you put an FXT cluster, or we call the edge filer, in front of your existing storage on the right, and your clients now, as they access files that are normally located on your filer over here, we actually start to learn about the patterns of the I/O and handle all the I/O locally here. So all reads and writes get digested locally here, providing an optimal latency response to these clients, high throughput, low response times, and essentially offloading this filer. As a second benefit of that, we start to offload this network link as well. And what that means is, as you need more and more performance, you no longer need to beef things up over here. You just add more and more of the FXT nodes to your cluster, and that gives you a much better performance footprint than what you're looking for. Now, also, once you start running out of capacity due to growth in the workloads, you can now add more and more disks to your core filer and no longer have to buy expensive fiber channel disks or just high-speed disks. You can buy big and slow SATA disks, essentially. Now, what happens in a normal environment is you run out of other resources on this that prevent the growth. So you add a second file to your environment, or you have a different workload that perhaps this file is more suited for. You have an access problem at that point where now you have to tell your clients, I got to go to filer A for dataset A and filer B for dataset C or whatever. And essentially, we can now tie all this together in a global namespace so the clients can just change directories and get redirected automatically to the files that are homed on these various filers. Additionally, you can actually locate filers in the cloud. And what that means is, since we're so effective at offloading this communication between these two links, you're now getting an optimal response without actually having to traverse this WAN link, store the massive at-rest data in the cloud, and have a local latency experience here at the edge. In addition, we do have some analytics that offer you deep insight into what your clients are actually doing. What are they reading, what are they writing, what kind of files are they operating on, what kind of I/O patterns are they generating, and stuff like that.
Okay, so basically what we've got is we scale performance here, we scale capacity here, even in the cloud, and then you give me analytics to let me know what's going on.
That's exactly right.
Awesome. Thanks very much for your time.